Hi, I'm Janato Ferdos, and today I will be presenting my coursework on email spam detection using artificial intelligence. The aim of this project to design and implement AI-based spam detection system using logistic regression. In this project, I used machine learning to build a system that can automatically classify emails and spam or harm. Now, per application area review. Email spam refers an unwanted emails such as advertisement, fake offers, or scam messages. These emails are sent in large number and often have no value for the user. Some spam emails are dangerous because they may contain phishing links or malware. Spam emails are a major problem today. Million of emails are sent daily, making it impossible for people or organization to manually check every message. Spam waste time, reduce productivity, and can use seriously security risk. To solve this problem, artificial intelligence is used. AI can automatically analyze email content and learn patterns from previously identified spam emails. When a new email arrives, the AI system checks it and quickly decided whether it is spam or not. Popular email services like Gmail, Yahoo Mail, and Outlook use AI-based spam filters to protect users and improve email security. Here is my reference I have used for part A. Then part B, comparative evaluation of AI techniques. To solve the email spam classification problem, three AI techniques I compared: logistic regression, decision trees, and to optimize logistic regression. Now, logistic regression. Um, Logistic regression is the spam and fast method that classifies the emails as spam or not spam based on learned patterns. It is easy to understand and works well for real-time email filtering, but it cannot handle complex spam patterns. Second, decision trees. Decision trees use role-based decisions to classify emails. They are easy to interpret and can capture non-linear patterns. However, they often overfit the data and do not pattern well with large text-based feature. Finally, optimize logistic optimize. Optimized logistic regression improves the basic logistic regression model by tuning its parameters using techniques like grid search. This helps reduce errors and improve accuracy while keeping the model fast and reliable. After comparison, optimized logistic regression was chosen because it provides the best balance of accuracy, speed, and simplicity, making it suitable for real-world spam detection system. Now I will explain part C for my coursework, which is the implementation part. In this section, I will show how the email spam detection system is built using machine learning, and I will explain the output after running each part of the code. The dataset used in project contains 1,580 emails with no duplicate enters. And 837 emails or 53% are harm, and 743 emails or 47% are spam. This means the dataset is fairly balanced, which is important because it allows to evaluate the model fairly without bias towards one class. Each email contains two details: the message text label included, whether it is spam or harm. You can also see the balance clearly in this distribution bar chart. Then pre-processing. Before training a machine learning model, the email text must be converted into numerical form. To do this, I used TF-IDF vectorization. TF-IDS numerous how important a word in a specific email compared to the entire dataset. Um, I used up to 5,000 feature Include unigrams and bigrams. Remove common English stopwords. The level of encoded numerically 0 for ham, 1 for spam. This processing step transfer raw text into from format the model can learn from. In this step, I remove unnecessary columns that do not contain useful information. Clean a dataset with fewer columns. After removing these columns, the dataset become cleaner and easier to work with, which improve processing efficiency. Then I then rename the column to make them more meaningful and readable. Column label and message. This output shows that the column names are cleaner, making the code easier to understand. And also you can see, next I convert the text label into numerical form where spam is represent as 1 and ham as 0. Then in this step, I separated this email message as input data and the labels as output data. Variables X and Y uh, created here contains X contains the email text and Y contains the spam or ham labels. The separation is required for training machine learning model. Since the machine learning model cannot understand text directly, I use IDF vectorization to convert text data into numerical form. Uh, sep, uh, sep, uh, Numerical feature values. This outputs represents this email message is numerical format, allowing the model to analyze word importance. Then part D, testing and evaluation. The dataset is then split into training and testing sets. Training and testing data created. The training data used to each the model, while the testing data is used to evaluate its performance. After preparing the data, I created a logistic regression model. Model initialized. There is no visible output here because the model is only being created, not trained yet. Try different. Next, I trained the logistic regression model using the trained data. Model training competes successfully. At this stage, the model learns pattern from the email data, such as words commonly found in a spam email. After training, I used the model to make a prediction on the test. Predicted values 0 and 1. These values represent the model's prediction where 1 indicates spam and 0 indicates harm. I then calculate the accuracy of the model. I am accuracy score, for example, above 95%. This accuracy score shows that the model correctly classified of the email. One major advantage of logistic regression is interpretability. The most influenced spam indicators include words such as HTTP, price, pills, info, and meanwhile harm indicators includes thanks, attached, subject, question. These patterns align well with real-world experience and confirm that the model learned meaningful destination rather than random noise. Mm, this confusion matrix provides a more detailed look at model behavior. The results show 144 true harm emails correctly classified, 150 true spam emails correctly detected, 11 positive and 11 negatives. False positive hide lightweight emails, while false negatives allow spam into boxes into inboxes. This model maintains a good balance between these two risks. Then, 99.76%. 99.76% training accuracy and 93.04% test accuracy. This small gap between training and test accuracy indicates good generalization rather than overfitting. And precision recall to F1 score around 93% for both spam and hub, showing balanced performance across the both classes. Now part E. uh, Equity, diversity, and inclusion are important in AI-based spam filters. Even though spam filters seems neutral, they can become biased if they are trained on limited data. This may causes real emails from international user, non-profit groups, or small business to be wrongly marked as a spam. To reduce bias, spam filter should use deliberate training data to be checked regularly and allow user report mistakes. Explains why an email marked as spam also helps user truly their system. Accessibility is also important. Spam filter should be simple to use, the should or not block important emails, especially for user who depend